Time value of money is a important concept when it comes to finance, especially when it comes to financial planning. In Excel, there are embedded formulas that will allow us to calculate parameters that we want to calculate. The thing that you want to get comfortable with is that there are few parameters, 5 to be exact, that are in the time value of money. Present value is obviously at any point when you're looking at where you're starting from, it's called the present value. Future value is in the future, could be here is future. So this number over here would be future compared to this number and so on. And obviously further down you go, your future value, will grow. N is the number of periods, NPR. In the Excel, N is, the formula is, the variable is called NPER. So you have the, depending on how far you are, N1, N2, N3, so on. For example, this would be year 1, year 2, year 3. PMT is the amount that is in each period. So the formula, we will look at PMT, how much money is there on every period. R is a growth rate, which means what is the relationship is how the money is growing from present value to the future value. And again, like I mentioned, NPER is the number of periods. So the key thing is to really look at a problem and decide of these 5 things, what information do we have available and what information are we trying to calculate. So let's look at the first one. In the first one, the problem states that if you invest $10,000 today and do not add any more, calculate what the future value will be. So here, let's think through what we do know. We know the present value, which is 10,000. We want to calculate the future value. The NPER, we're going to do different scenarios for 5 years and again for 10 years. So that NPER would be the 5 years or the 10 years. And the rate, is different for each one of these. First one is 1%, second one is 2%, third one is 3%. PMT, which is the amount added, there isn't any, so that amount will be 0. So when we use to calculate future value, obviously, so what we know is we are calculating the future value. We know the present value, which is $10,000 we are adding. We know that the number of periods is going to be either 5 or 10, and we know the R is going to be 1, 2, or 3 in 3 different scenarios. So the way you do it is you basically go to the formulas on the top, come down, find financial formulas, and then you go down till you find future value, which is, FV. So if I click on that, a box will open up. So here, if I'm doing the first one, and again, I set this thing up over here, so I have rate 0.01, which is 1%, 0.02, which is 2%, 0.03, which is 3%. And then I'm calculating the future value. First one is done at the n equal to 5, and the second one is done at the n equal to 10, which is what the problem is asking us to do. So I'll just do one as an example. Let's say we were trying to do, we'll do this one over here, okay? So we're going to do this one over here. So I'm going to go to the formula, and I'm going to go to the financials, and I will find the future value. The box opens up. My rate is going to be, if I'm doing this one, I'm going to click on this cell, which is going to be that number. NPER, let's say if I'm doing this one, 10 years. PMT, we don't have any, so we leave it a blank. Present value is going to be this number over here, 10,000. But notice I put this in minus. If I put it in the plus, I will still get the same number, except it's going to be a minus. The way the time value formula works, if the money that we are giving out is considered as a negative number, money we get back is a positive number. So in this example, if I'm investing $10,000, I'm giving $10,000 to the bank. So that's why it is negative. For here on that, if I click OK, I'll get the answer, which is basically over here. So if I want to continue to do other ones, I will repeat it and I can get that. Okay. Now let's look at the second problem. The second problem is if you put 10,000 like we did in the last question, plus we're adding $1,000 more every year. Now what would happen to our future value? Like how much will we have in 5 years and 10 years? So here again, we know we're calculating the future value, so we're going to look for the formula. So we go to the formula. So here we're going to do is to just click it over here. In this case, they're asking us to do $10,000. We're putting it right now. Another $1,000 every year. What is going to be the future value in 20 years? Different scenarios: 1%, 2%, 3%. So let's do the first one over here. So I'll go into the formulas, financials, and again, because I'm calculating future value, I'll do the future value. The rate, if I'm doing the first one, which is this number over here, NPER, we know the problem says to do 20 years, so I put this in here in my Excel spreadsheet. I can just click on it. PMT is the annual amount we are also adding into, let's say, the 401k or 403b. So that's a minus $1,000. Again, why is it minus? Because we are giving our money away into the 401k, and the future will get it back. Present value is I'm starting out with 10,000. Remember the problem said if you put in 10,000 today, which is minus 10,000, plus add $1,000 every year, that's a PMT, and then in 20 years what we're going to get. So if I click on it and okay, then get 34,200. So here you can see that in the first one we basically did $10,000 and we did not add anything, and here we add extra $1,000 a month, and obviously because of adding more money and compounding effect, we have a much higher number. Again, if you want to do the other ones, we'll do exactly the same way. The third problem is that if Julie has $500,000 in her retirement account, which means she's retired, and now she will need the money to live off. If she invests in a conservative investment that will give a return of 3.5% a year, and if she wants her money to last 30 years, how much can she pull out at the end of every year for the next 10 years? So now let's look at each of the parameters. What is the present value? Present value is 500,000 because that's what she has. Future value, in this case, it does not apply, so we will not worry about it. Number of years she wants to be able to have that money last is 30 years, so NPER will be 30. How much money will she get every period is what we are going to calculate, and the rate that money is invested at is 3.5%. So R is 3.5%, PMT we're going to calculate, NPER is 30 years. There is no future value because by the time she is done, her money will be, will end up with zero, and she's starting with $500,000. So here we are going to solve for PMT, which is the amount of money she will get every year. So if I go to the formula, I'm going to just put it over here right next to it where I've done it. If I go to the formula, financials, and we are going to calculate the PMT, so I'll go down till I find PMT here. Again, the box opens up. What is the rate? Rate is this. Number of periods is 30 years. Present value, again negative. Why? Because we're giving the money to the investment or the annuity for which we'll get the annual amount as an income, so we put that in. There is no future value. If I click the number, I will get 27,185, which means that if you put in $500,000 into, say, an annuity or someplace, and the investment or the annuity is going to make 3.5%, and you want the money to last 30 years, you can pull out 27,185.67, and the money will last for you for 30 years. For example, if somebody says, gee, I want the money to last for, say, 40 years, I can go change that number, make it 40 years. Obviously, she can take out less because the money has to last a lot longer. If the money has to last only 20 years, then obviously she can take more out. So this is where you can see the connectivity between all these numbers. I'll go back to what the problem is, which is 30 years. The next one is that has to do with the mortgage payments. So John wants to borrow $200,000 to buy a house. He's going to get a 30-year mortgage with an interest rate of 4%. Calculate the monthly payments. This is important because it is a monthly payment. So typically when we pay a mortgage, we don't pay annual amount. We pay a monthly amount, so we have to account for that. And we will also do the calculation again to see what if he gets a 15-year loan, what would the difference be? So for each scenario, a 30-year and a 15-year, we want to calculate his monthly payment that he has to pay to the bank. And over the life of the loan, which is 30 years, how much interest will he pay? We'll do it once for 30 years, and then we can do it again for 20 years. So here, what are we trying to figure out? So let's look at all the parameters, right? Present value is the money we are borrowing it, which is in this case is $200,000. We're gonna pay our mortgage off over 30 years, so number of periods will be 30. But because it is monthly, we are going to account for that there are 30 years times there are 12 months per year, so we will have 360 periods we're going to pay our loan off on. There is no future value. Obviously, at the end of the life of the loan, the principal is everything is all paid off, so we don't worry about that. Rate in this case is going to be 4%. So how will we do that, right? So let's look at doing it again over here, right? I have done it here once for 30 years, and I've done it here again for 15 years. But I'll do it again here, so you can see it for calculations. So we want to do is to write down. I'll just write down these numbers again as an example. So we know we want to borrow $2,000. We know that the interest rate is 4%. But because we want to do it on a monthly basis, we want to divide it. So we're going to take that number up here, as you see, and I'm going to divide it by 12 because I want monthly interest. That's why we got that number. The annual period is, first one is 30 years, so we put that 30 in here. But because we're going to do monthly periods, we need to do is to take, take this 30 years, and you can see I'm doing it up here, multiply it by 12, and I got 360 periods. So now if I want to calculate the PMT, I'll go to the formula, get to financials, do the PMT, find PMT, box opens up, rate here, but this time remember, because it is a monthly payment, we are going to add the monthly rate, which is this cell over here. Number of periods, again, because it is monthly, we will add this cell, which is 360 periods. Present value, we are borrowing it $200,000. There is no future value because at the end of the mortgage terms, everything is done. If I hit it, I'll get the answer for 954, which is the number you see over here. Now, if I wanted to do this thing again, but for a different period, let's say I just copy this and put it over here. Move this around a little bit. And now the only difference is the amount is the same, the rate is the same, so the monthly rate will be the same. The only difference is going to be the amount of term. If it's a 15-year, I'll just make that 15. And it's going to calculate, there are decimals here to make it bigger. It's going to calculate the amounts. Obviously, for a 30-year mortgage, we would be paying a lot less per month because it is spread over a longer period. If you want to pay it off earlier in 15 years, which would mean 180 periods, you will pay it off in 147,938. Now, the second part of the question was, how much interest will we pay, or John will pay, over the life of the loan, right? How much interest will we pay? So the way to figure that out is basically you figure out what is the total amount you will pay over the life of the loan. So let's say if I take this one, which is the 30-year time horizon, the amount of money, so I'll write this thing down, total amount to be paid over life of the loan, right? That's what we want to pay. I'll move this over here. Let's see, cut, move this here, let's have some room, paste. So the first one over here is going to be that I am paying this much amount, and I am paying it for this number of periods. So I'm paying $954.83 for 360 times. So basically, over the life of the loan, I am going to pay $343. Similarly, here I'm going to pay $1,479.38 for 180 periods. So here, basically, if I do the calculation, I will get I'm going to pay 266. So as you can see, that typically when people say, gee, you pay almost double for the loan amount because you're borrowing 200, but by the time we get done paying the bank, because we have to pay interest along the way, we're gonna end up paying 343 over the life of the loan, but we're gonna pay less in the case of 15 years because obviously we are paying a little bit earlier, so there's less compounding effect. Now from this amount, we know that we are getting 200. So the question is how much of this amount 343 is the interest? Is going to be 343 minus what we got as a principal. So that's the reason why we have 143,739. Similarly, for the 15-year, we are paying 266,287 over the 15-year or 180 payments, but we were paid upfront to 200,000. So the interest we are paying is 66,287, which is really this amount, 266,287 minus the 200. And as you would expect, if you borrow the money for a shorter period, you will end up paying a lot less interest. So in this case, for 15 years, you will pay an interest of 66,000. If you borrow the money for 30 years, you're going to pay a lot more interest. So that's how you would do it. Okay. The next problem is similar, but we're looking at it from a credit card. Okay. So here, John has a store credit card with the annual interest rate of 20%. It sounds like pretty high, but typically you're going to find a lot of the store credit cards, if you really look at it, after the teaser period, they may give you for like maybe 8-10% up front. After that, they go up to 20 plus percent. For example, if you look at the QVC credit card, if you don't pay on time, they basically say, okay, you can get it and pay over 6 months. Yes, they won't charge you interest, but if you start to miss a payment, if you look at the fine print on the TV screen sometime, it says that the interest rates they're going to charge is 29%. So yes, some of these store credit cards, I'm not talking about Visa or MasterCard, they could be a little bit lower from the bank, but the store credit cards, your Macy's, your Lord & Taylor's, they have a pretty high interest rate. So 20% is not that unlikely. Now, so the monthly will be obviously 20% divided by 12, which is 1.667. So if the annual interest rate for the the store card is 20%, the monthly is divided by 12 is 1.667. Now his current balance is $5,000 for his account, and its minimum requirement that they will say you got to pay is 100, right? So let's say he gets a statement and he says, all you got to do is to pay a minimum of $100 and you are not going to be delinquent. The problem is that when you do that, it will take you a long time. So the question is this: if I want to figure out if John has $5,000 of debt in the credit card, and they're charging 20% annual or 1.6667 monthly, which is 20 divided by 12, and all he's paying is a minimum of $100, how long before he will pay his debt off? Assuming he does not charge any more. Just basically that's what it's going to do. So how would we do that, right? So let's think about it. What we know, what we don't know. We know that the present value is $5,000 because that's the money he owes, right? We know that the monthly rate is 1.667, which is 20% divided by 1.167. So that's we know R. We know that monthly payment right now he's planning to put only $100 a month, so that's PMT is 100. And if we know in the future, obviously it will go to 0. And the question is, how many periods NPR will it take to do that? So, in order to do that, we basically are going to, what do we have to calculate? We have to calculate NPER, So let's look at it. Now, so let's say here is a problem. I'm just going to take this piece of information. So here is the, his money that he owes, $5,000. The first example, which is over here, is what we are going to do, which is I'm just going to highlight in yellow. Okay, he's planning only to pay, excuse me, $100. Interest rate annual is for his credit card is 20%. So I'll just pull that over here. Okay. So we make it monthly, obviously we're going to just divide it by 12. So that's going to be 1.667 kind of number. And now we're going to calculate the number of periods number of periods, this is what we want to solve for. I'll make that a green so you can see it. We want to solve for this thing. So what we're going to do is going to go to the formulas. We're going to go to financials. And we are looking for NPER. Here we go, number of periods. So box opens up. Rate, because we are doing we're trying to figure out a number of months, we're going to put the monthly rate, which is this cell. PMT is planning to put $100. Present value, that's what his current balance is, starting out with $5,000. So if I do OK, it will take him 108 months to do it. 108 months to pay that off. So what is that? Number of years, just over here. So I can take this number of months and divide it by 12. It will take 9 years for him to pay off his $5,000 debt. If he's only paying $100 and the charge card interest rate is 20%, and he's not charging any more. If he charges more, then the amount is going to even grow. So the monthly rate is 1.667, which is 20% divided by 12. And we calculate the number of periods using the Excel formula. It's 108 months. Over here, if I want to look at a number of years, I divide the number of months by 12, I get that. So you can see that he is paying, quite a bit of money for a long time. So the question is, so if you want to figure out how much interest he's going to pay, so let's first figure out how much is he going to pay over the 108 months. So he's going to pay $100, which is this amount, multiplied by number of periods, which is that. So he's going to pay for that long. So he's basically going to pay $10,839 for the credit card balance that he currently has $5,000 if he's only going to pay $100. So which means that his interest amount that he's paying is the difference between the total he's going to pay, subtracting the amount, I want to put and then accounting for the balance. So he's going to pay $5,839 as an interest over the life of the loan. And that's the reason if you can pay faster, and again I did it over here, but if I'll just show it over here, in this little box over here, so let me just make it a slightly different color. I'll make it a blue. So here you can see, right? So keep an eye on how long this is going to take, and I'm sorry, how long it's going to take. I'll just make this a little bit smaller so you don't need all these decimals. So it'll be 108.4 months, and this over here is the number of years. If I reduce some of the decimals, 9 years, that's what it's going to take. Now, if he's able to put in more amount, let's say if you can put in 150, it will take him only 4 years versus 9 years. And again, I did it over here. For putting in 150 goes down to 4 years, 200. So if I change that to 200, you can see that you can pay it off in 2.72 years. And you can see the interest that he's paying. If he does only $100 a month, interest he's going to pay over the life of the loan is more than what he basically got on the credit. He's paying $5,800 for the debt of $5,000. If he can pay $150 a month, you can see the amount of interest he's going to pay will be a lot less, and he can pay it off in 4 years. If you can just go to 200, the interest amount will drop to 1,527, and you can pay it off in 270. And if he can go to 300, for example, if I just change that, obviously he can pay a lot less time, and his interest is going to be only $900. So that's really the power of timing of what you're going to do that. Now in the bonus question, I said that Jill has a credit card balance of $10,000, so that would be the present value, like we did with John's. Interest rate is 15% in this example. So we'll divide that by 12 to get monthly. She plans to pay $300 a month, okay? And she also has a monthly charge, which means she has a health club account that automatically charges $50 per month. So here the twist is that what is going to be her PMT, right? So we know that the present value is minus $10,000. That's the money she owes. She's going to put in $300 towards the monthly, to the credit card, pay off $300. But she has an automatic charge that goes to her credit card of $50. So the reality, what she's really paying is $250. Why? Because she's paying $300, but automatically every month, bank charges $50, towards the her health club. So now what we are doing is that when we want to calculate the number of periods, so again, this would be her beginning balance. Her PMT is going to be $250. Why? Because even though she's sending a check for $300, there is a $50 charge towards her account because of the health club. She's really paying $250. Her interest rate is, in this example, I'm using annual rate of 15%, which means on a monthly basis, if I divide that by 12, I'll get 0.0125 with a monthly. Now, if I want to calculate the number of periods, do the same thing. You go to the formula, go to financials, go to the NPER. The rate is going to be, again, because monthly. Payment is $250. Again, why $250? Because she's paying $300, but then it's a $50 charge every month, so net is $250. Present value is the amount she owes right now, and if I click it, it will take her 55.8 months to pay off. And again, total amount of payment she's going to pay is going to be number of months. She's going to pay $250, and that's the total amount she's going to pay over that period. And then how much interest is that? If she's borrowing, if she's paying this much and she borrowed this much, then her amount that she's paying over the amount she owes is $3,949. That's the interest. And again, if I want to do this in number of years, the monthly we calculate a number of years. All I do is to take the number of months and I divide it by 12, and you get that 4.66. So you can see how it can change, how quickly it can change. For example, if she can start to pay, instead of $300, if she starts to pay more, if I increase this $250 to maybe $350, she can pay more, then obviously it will reduce the amount of time it will take to pay. So that's why, when people have credit cards and they have like huge interest rates, and most credit cards, especially the store credit card, do, that's why it takes a very, very long time to pay off and all the interest they pay. So I hope this was helpful. In a nutshell, remember, it is a very, very important tool depending on what you're solving for. Are you solving for a future value, which you typically would do if you're looking at a portfolio, looking at the mutual funds, we're looking at a 401k, how much money we are putting in, what's going to happen. If you're looking at the annuity, which means in the case of example that we did, for somebody has amount and she wants to know how long, and she wants to collect money for 30 years as an income, we can figure that out with the PMT, if we know the number of years. So as long as we know 4 out of 5 for any one of these parameters, we can solve for the last one. So that's really is what time value is good for.